kind of run through a couple of things that I wish I had known when we started about arrays versus slices and kind of how they work internally. I work at Nozzle. We do marketing software. Everything's built in Go and Angular. I love this because I think I'm awesome. I love the matrix, but we all should know we're kind of nerdy, and we like it. So enjoy it. So what's an array in Go? You can define it. You don't see it very often, but you've got the syntax. You actually put how long the array is in front of it, and it works kind of how you'd expect. And you can define an array that's too long, either by specifying 2, and I just learned this today, or if you put the ellipses, it'll count it for you. The compiler will count it for you and create the array at the appropriate length. And so an array versus a slice. An array can't be resized, but it is comparable. I read there's an article, I think it was Cloudflare. They were using some structs as keys in a map, but they couldn't use. You can't use a slice because it's a variable length. It's not comparable, is what they call it in Go. Comparable often means you can use it as a map key. You can use it with an equal or an unequal operator. So there's some cool things. I think about it as like a MySQL char, whatever you want to call it, versus slices, which are backed still by arrays, but the arrays kind of become invisible to you as a developer. They're not comparable. They can resize, and I think of it as like a bar chart. And again, so looks very similar, except you just don't define the length. So this code here behind the scenes will create an array that's too long, kind of the same as the top one, but as you append to that array, it'll continue to grow the capacity. And what is the slice actually? And this is kind of what I had an aha moment at one point. It's actually a struct that has a pointer to the beginning of your objects. It also has a length and a capacity. And so and a lot of these graphics and things that's shamelessly stolen from the Go blog. There's a couple articles I have references at the end. So your pointer points to the beginning of an actual data-backed array, and then when you run the make command, it creates an array of length 5, but you're accessing it as the slice. It also has a capacity of 5, since you didn't pass in a third argument that would set the capacity if you want it to be different from the length of the slice. And really simple. When you make a slice of the slice, this takes just 2 to 4. It's those 2 pieces of the array. It doesn't actually copy it. It still points to the original parts of the array. And this is what really kind of got me. I know some of that other stuff is very kind of rudimentary, but this, a lot of times you'll see slices pass and it's like, wait, but it's a pointer, but it's not a pointer, and what's going on? If you pass an array as a parameter, it's actually copying the whole thing. If you pass a slice as a parameter, it's actually making a copy of the slice element. It's those 3 simple fields in the struct. And what that means is you still have pointers to all the original items, but you can't actually change the length or the capacity of the backing array. So it comes in handy a lot of the time, but use it carefully, because you are editing. Even though you might think you're passing it by value, you still have a reference back to your original object. And then slices of pointers. This is one that we kind of went back and forth a lot how to use. So this is kind of a simple thing that we use in our code. This is just a clients function. We're decoding some clients from JSON, and I don't know if any of you use Couch. They have, instead of being like a straight up REST, you can put can put your JSON in and it checks to see if an ID is there. If there is an ID, then it updates it. If there isn't, it adds it. We've kind of done the same thing with our API. So when I get the body in with an array of clients, I decode it from JSON into, kind of show you. This is obviously simplified, but I'll decode it into a slice of client, but then I'm also creating 2 separate slices depending on whether or not the ID was passed in, which are a slice of pointer to client. And so kind of up here you can see I get 2 slices of pointers plus my actual slice. And then I can send just the slice of pointers into my add and my edit functions. I'm not copying the data that client contains, but I'm still able to manipulate it, change it. When I add it, I can insert the ID, change, modify dates, all that kind of stuff. And so kind of what we've come to, and I'm interested if anyone has different thoughts, but typically we prefer slices of the actual object rather than pointers. Usually we don't have a need to have that extra dereferencing step. And unless you want an actual nil object versus an empty struct. And one thing that bit us at one point is be careful if you're not using the pointer. If you call json.marshal on it, it will succeed, but it base64 encodes it for no good reason. and it's something that Dave said they will not fix in Go 1 because it's not a bug. That's just how the implementation works, and maybe someone is relying on that. Then there's this is again copied from some things. There's some really cool slice tricks you can use. Kind of like Ian was saying, there's some, people are annoyed about some lack of generics aside from slices, but there's some cool tricks you can use. Some of those are simple, but cutting or deleting, you can, most of the time when you're manipulating your slices or arrays, you're having to copy the whole thing. But you can see like this delete one's kind of interesting. You're actually taking the first half of the array and then taking the second half and just kind of moving it over the item in the middle and appending it. It changes the length but doesn't have to reallocate a whole new array for it.
I believe that will copy.
Will that copy?
Yeah.
Okay.
It doesn't know the move thing you just said. I believe it has to reallocate the whole size.
Okay. Yeah, I'm not positive on that one. The one that I actually use. So, and again, I've got a link to where they talk about all of these. And they have a couple different options beyond these on the page that let you know. Some of them do reallocate, some of them you can do a little bit trickier things to not reallocate. Some pop and push, just how they might look in Go. This is an interesting one that we use in a couple places to filter without allocating. So B and A, they both start off pointing at the same backing array there, but you're setting the length of A to be 0. And so, or you're setting, B to be this. Let me start over. So B is pointing at the same backing array as A, but with a length and capacity of 0. And then as you're looping through it, you can, as you're filtering, you can say, append onto B, it'll overwrite the same place in memory that existed in A. By the time you're done, you just have B, which is your filtered list of items. So this was just a cool little trick that we use in a number of spots. And here's some links for that. And that bottom one, Go data, goes into even some more detail about structs and how specifically memory is allocated as you're doing those things. And thanks. Anyone have any questions or anything I said wrong?